Welcome to Contemporary Math. Today's lesson is 13.3 on frequency distributions. So our lesson on frequency distributions has to deal with, once you gather all this data, how do we start organizing it so that we can actually analyze it? So today is going to be all about organizing our data. So a lot of times you get many pieces of data. For your experiment, you're getting 40. So a piece of data is a single response to an experiment. Now as you get many responses, many pieces of data, looking at it can become a little bit overwhelming. And so one thing we can do to make this a little bit easier to understand is to use a frequency distribution. And so what this is, it's going to be listing every observed value and the corresponding frequency of each value. Okay, and I wrote the word how many right here. So frequency just answers the question, how many times did that observed value come up? Here's an example where a frequency distribution is going to be helpful. It says the number of children per family is recorded for 64 families surveyed. Construct a frequency distribution of the following data. So fortunately, this data is already ranked, meaning it's put in order. And that's one tool that can help to analyze this data. So when we look at this, all the values go from 0 to 1 to 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so as we list this, we want to list our observed value. And that is the number of children. So we have some respondents who said 0, some who said 1, all the way up to 9. So these were all the possible pieces of data that we're looking at. Now over here in the right column, we're looking at the frequency, and this is the frequency distribution. We want to see how is the data distributed throughout these observed values. So this right here is answering the question of how many families gave this as their answer. So what we have to do here is simply count. So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, those who said 1 child, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And you can kind of count these up as we go. I get 18 there. I got 11 for 3. 6 for 4. Okay, 4 families said they had 5 children. 2 families said they have 6 children. There's 1 family for 7, 2 for 8, and 1 for 9. Now what I've done is I've left a little extra space down here, and I want to find the total of all the frequencies. And we're going to add them up just to make sure that we have every family accounted for and we didn't make any mistakes. So we're just going to add these up here. 8, 11, plus 18, plus 11, plus 6, plus 4, plus 2, plus 1, plus 2, plus 1. And we get a total of 64. And if we check back at the beginning, there were 64 families surveyed, so we know they're all accounted for. So now answering these questions over here becomes easy by looking at our frequency distribution. It says how many families said they had 5 children. Okay, so here is the number of children, 5, and that would be a total of 4 families. How do you know all the pieces of data are accounted for? Well, all the frequencies add up to be 64. Now this question, how many different observed values are there? So looking at this, we actually had 10 different answers. Now eventually what we're going to do is we're going to take this information and display it in 2 types of graphs. We're going to be looking at histograms and line graphs. So these are just 2 visual ways of representing a frequency distribution that help us analyze this even more. So in looking at this, you can see the highest frequency was right there at 2 children per families, and then it was also surrounded by 1 and 3, and so this is pretty much what I would expect from this type of question. As the number of observed values increases, when it gets more than 10, it's often helpful to start grouping the data into classes. Okay, so we don't want to have this huge long list of observed values because then it's not really very useful. So often we group these into classes to provide more information about the distribution. So that would be difficult to observe if it was ungrouped. Okay, this is often done with like age groups. So we don't care so much the difference between 16, 17, and 18-year-olds, but if we group 16 through 18 together, it kind of tells us something about that upper teenage group. So a couple of rules when you're creating these classes. Number 1, the classes must all have the same width. In other words, they have to contain the same number of observed values throughout all the classes. So we have to keep these spacings the same. Number 2, the classes may not overlap or have gaps between them. Okay. So our groupings can't overlap, meaning they can't share observed values, and we can't have gaps between them, meaning we can't have observed values that would be left out somewhere in between the classes. Number 3 kind of falls along with that. Each piece of data must belong to one and only one class. And number 4, the width of the class needs to be set up. It's chosen arbitrarily so that the data is grouped anywhere from 5 to 12 groups. So again, if we make our widths too wide and it encompasses so many observed values that we have fewer than 5 groups, now all the data is clumped together and it's really not helpful. And if the width of our classes are too small, that we have so many groups, then everything is going to be so spread out that it's not helpful either. So that sweet spot is right between 5, and 12. So now we just have a couple terms that we want to define and talk about. So the class width, we've been mentioning this. And really this is the number of observed values that belong to a class. And I'm going to write possible because when you deal with a range, sometimes you don't have them in there. Now when you deal with a class, you're going to have a starting number and an ending number. So let's just say we have a class where our first one is a width of 0 through 4. Okay, so we think how many observed values are in 0 through 4? Well, we have 0, 1, 2, 3, and 4. So that is actually a class width of 5. Now the lower class limit, this is going to be the set of all numbers on the lower end of all the classes. Okay, and basically what it is, it's the number on the left. So the lower class limit of this example, 0 through 4, is 0. Okay, now the upper class limit is just what it says, the upper. So it's the set of numbers on the upper end of all the classes. And it's going to be on the right. So looking at our class from 0 to 4, 4 would be the upper limit. Now as we create these classes, they all need to have the same width, and they can't have any gaps. So if we're dealing with 0 to 4, it looks like we're dealing with integers. So the next one is just going to start off with 5. Now you can see here the class width is also the difference between the lower limits. So 5 minus 0 gives us 5. The class width is also the difference between the upper class limits. So if we do 4 plus 5, then it gives us 9. So under class width, if you have room there, go ahead and add that in. It's going to be the difference between consecutive, lower or upper class limits. Okay, so if we wanted to add another class, well, we could go 5 plus 5 and start at 10. Notice that goes right from 9 to 10. And then to get the next upper limit, we would go 9 plus 5, which would be 14. Let's go ahead and add one more class. So 14 would leave our next class to be at 15. Notice 10 plus 5 is 15. And our upper class limit would be 14 plus 5, and we get 19. Now if we count the observed values in each of these, they should be 5. So 5, 6, 7, 8, 9, it's 5 numbers. 10, 11, 12, 13, 14, that's 5. And then 15, 16, 17, 18, 19, that's 5 number. So if we wanted to list all the lower class limits, we would list 0, 5, 10, and 15. All the upper class limits would be 4, 9, 14, and 19. The next thing we want to talk about is something called the class midpoint or the class mark. Now this is going to be used when we make our graphs. So rather than listing classes, we actually use the class marks or the class midpoints. So it's the middle of a class, and to be able to find this, you actually take the lower limit plus the upper limit, and then you divide it by 2. So it's a very simple average of the two limits there. The next thing we can talk about is the modal class. And modal, we think of the word most. So the modal class is the class with the highest frequency. Okay. Now one note here, there might be a tie for the most. In that case, we would have more than one modal class. So there might be more than one. All right, so let's continue here. Next up, we just want to practice these skills a little bit. So find the width of each of the following classes. So if we're just given 0 through 9, one thing we can think about is what would be the next class? Well, the next one would start at 10. And if we know the class width is the difference between the lower limits, we would do 10 minus 0, and so our class width would equal 10. You could also count the numbers from 0 through 9 to get your answer there. So let's demonstrate that. If we want to go 8 through 11, we could do 8 plus 9 plus 10 plus 11, and so that's a total of 4 numbers. Now, it turns out that classes can also be made up of decimal points. So if the data you're dealing with involves decimal points, then your class widths also will most likely involve some decimal points. So again, we can think here, this is to the 10th place, so the very next one would go to the 10th higher. So 5.7 would leave it off to 5.8, and we're just going to do 5.8 minus 2.6. And this gives me a total of 3.2. All right, in our next box, we want to be able to list the next 3 classes given the first class. So if we have 0 to 9, we know it's going to lead off with 10. Now because we determined the class width was 10, we can just add that on to the upper class limit. So 9 plus 10 is 19. The next one will start with 20. And then again we add 10 to 19 and get 29. And then the next class would start at 30. And you can kind of see a pattern developing here, and this is going to go up to 39. In our next example, 8 to 11, because it's integers, we're going to go up to 12. Okay. We determined the class width was 4, so 4 plus 11 is 15. Start at 16. Go 15 plus 4, we get 19. Next one will start at 20. Go 19 plus 4, and we get 23. So we're going to do the same thing with the decimals now. So 5.7, we're going to lead off with the next 10th, which is going to be 5.8. And this is going to go up to, let's see, we're going to do 5.7 plus 3.2. And so that's going to give us 8.9. So what should the next class start with? We're going to go a 10th higher, 9.0. How are we going to find the upper class limit? Well, we're going to add the class width to the previous upper class limit. So 8.9 plus 3.2 gives me 12.1. And then the next one's going to start at 12.2. Then we're going to add 3.2 to 12.1, and we get 15.3. Now our next box is going to highlight finding the class mark or midpoint. Same thing. So what we want to do here is add the two limits together and then divide by 2. So notice your class mark can be a decimal place or decimal point even if your numbers are integers. For the next one, what do? We add them up, divide by 2, gives us 9.5. And it doesn't matter if it's decimals, we do the same thing. 2.6 plus 5.7 divided by 2. That gives me 4.15. All right, so we're going to actually try this now on a set of data. We're going to use classes to help us organize this to be able to analyze it. So the table below shows the number of days to the 18th birthdays of 40 high school seniors. Create a frequency distribution with a class of 30 to 39 and answer the questions. So when we look at this data, it's kind of all spread out. It was like this is just the order that we receive the data in. So what we want to do is organize this, and on our left side we're going to have days to 18th birthday, and then on the right side is our frequency, which is the number of students in that range. Okay, so let's just deal with the classes first. They said the first class is 30 to 39. So that was given for us right there. So we just list 30 to 39. And then we just followed the same patterns that we've been doing. So here 39 will lead to 40. You can see the class width is 10. So this one has to go 39 plus 10, which is 49. Next one will be 50 to 59, 60 to 69, 70 to 79, 80 to 89, and 90 to 99. Now when we look at this, none of the data is higher than 99, so we can go ahead and stop there. Now, this is a little bit trickier than the last example we did. Because this is not in order, it's going to be very hard to count this. And so what we're going to do is just kind of keep a little bit of a tally going over here as we come across the numbers. So if I look at the number 70, we want to say, which class does this fit in? Well, it fits in 70 to 79, so I make a little tally mark and I cross it off to make sure I know it's been counted. Okay, and then you can go across or down either way. So 63 would belong in 60 to 69, and then we cross it off. 77 belongs in 70 to 79. We cross it off. 60 would go in 60 to 69. And we cross it off. 51 goes in 50 to 59. So you can kind of get the hang of how this is working. 64 goes in 60 to 69. 38 goes in 30 to 39. 56 goes in 50 to 59. 53 goes in 50 to 59. 36 goes in 30 to 39. 99 goes in our last class, 90 to 99. 67 belongs in 60 to 69. 71 belongs in 70 to 79. 47 goes in 40 to 49. 63, 60 to 69. Now we already have 4 marks. We can continue making marks, or if you want to make 5 in a tally, you just cross the 4. And so now we have a group of 5. 55. Okay, go ahead and complete these with me here. Alright, so nobody said being a statistician was easy, and really the work of a statistician is just to be able to present this information to others. So it's a little bit of work to organize all this data here, but now we're just going to take our tallies and we're going to write our frequencies. So we have 3, 1,
7.
So 60 to 69 gives us 11. 70 to 79 gives us 7. 80 to 89 gives us 7. And 90 to 99 gives us 4. Now we do want to total this up to make sure it adds up to our 40 high school seniors. So 3 and 1 is 4, 7 is 11, and 11 is 22, and 7 is 29, and 7 is 36, and 4 is 40. So we do have all 40 represented there. Now, we want to answer a couple questions here. What is the class width? So we already determined if we go 40 minus 30, that would give us 10. What is the modal class? This is the one with the most. So in this case, the most right here with 11 is 60 to 69. List all the lower class limits. That's easy. It's everything on the left-hand side. So 30, 40, 50, and so on. List all the upper class limits. So now this is everything on the right-hand side. What is the midpoint of the first class? So we want to take 30 plus 39, divide that by 2. If you put this straight in your calculator, make sure you put 30 plus 39 in parentheses. So we have 69 over 2, which is 34.5. The next question, what is the class mark? Mark and midpoint are the same thing. We find them the same way. 40 plus 49 over 2. So that's 89 over 2, which is 44.5. Now the next question says, what is the difference between the first and second class marks? So 44.5 minus 34.5, we have a difference of 10. Now how does this compare with the class width? It's the same. Now let's move on to our next problem. And this is going to be how to deal with frequency distributions that contain decimals. And we have income is what we're looking at. And then we want the number of families. So how do we tell where to start with our distribution? We want to have between 5 and 12 classes. And if you look at this, we have 15 numbers. So we can't really just list all the observed values, not to mention we would need to list all the tenths in between. So we're going to do this as a range. Okay, it looks like everything is placed in order. So we go from 16.8 and it goes up to 50.2. So one way we can do this, we need to figure out so that every piece of data falls within a class. So what we can do is find our difference here. So 50.2 minus 60.8. Okay, now we can decide how many classes we want to have. Okay, and let's just say we want to have 6 classes. So if we divide this by 6, it's going to give us a number, 5.56. So we know we need to pick something around that. So why don't we just pick 5.5? Why not? Okay, so we just need to start somewhere before 16.8. Why don't we just start at 16.0? Now if we know our class width is 5.5, the easiest way to do this is just to go ahead and add 5.5 to your lower limit. So we're going to do this right here. And we get 21.5. And all we have to do here is keep adding that 5.5. Okay. Now if we start our class at 49, I think that's going to incorporate our 50.2. So now we need to go and figure out the upper class limits. So we can just take our lower class limit and go down by 1/10. And that's going to work. So 21.5 will go down by 1, 21.4. Okay. Now we could keep adding 5.5s to this, or we can keep going down by 1/10. So here 27 would go to 26.9. Here 32.5 goes down to 32.4, sorry. 38 would be 37.9. 43.5 would be 43.4. 49 would go down to 48.9. Now this one we really can't go down, so we do need to add our 5.5. So 49 plus 5.5 is 54.5. Alright, so next we're just going to need to tally these guys up. So 16.8, that would fit right in here. 20.5 would also fit there. 24.8 would fit in this one. 25.3 would fit here. 25.9 fits there. 29.6 fits in that class. 29.7. 30.8, it's in the same one. 31.5, still in the same one. 33.8 would fit here. 35.7, the same one. 37.4, the same one. 38.7 jumps to the next class. 41.3, same class. 50.2, now notice there isn't anything in this class. 50.2 actually goes here. Now that's perfectly okay to have a frequency of 0 in there. So we have 2, 3, 4, 3, 2, 0, and 1. So that is frequency distributions with and without classes. Thanks for watching.